a short history of lean. It started with Toyota, and as some of you may know, Toyota developed their car company in the early 19th century and developed it more into more of a manufacturing company. And then we had World War II, which we dropped a couple of atomic bombs over there that just completely destroyed their manufacturing. So they were rebuilding this process in the 1940s and 50s, coming out of this World War, and looking at new ways to develop their manufacturing in a more efficient and more streamlined process. They were competing with the Goliaths in that day of the Ford and Chevrolets and Chryslers, and they were not winning at all. And so they wanted to get into America to sell their cars, but then also learn how Ford and Chevy, GM, and Chrysler were making cars. So they came over to visit us, and they toured the plants, and they saw a lot of waste. They were not impressed with the car manufacturing, so they saw a lot of waste in car manufacturing, a lot of inventory, a lot of rejected car parts that they were having to rework, and lower quality than they anticipated to see with the great product that Ford and GM and Chrysler were producing. However, they were very impressed with how we ran our grocery stores. And as some of you may know, grocery stores are ran in a just-in-time delivery system, which really lends itself to fresh produce and food. So they started to analyze the way that grocery stores were ran, and they started to implement some of these principles into manufacturing, which they called lean manufacturing. So they go back to Japan, and they start implementing this. They created this system and has been developing this for the last 60-some years. And it was named lean manufacturing in the last 20 years. So this manufacturing process has gained a lot of ground in car manufacturing, even so that many of their competitors, like Chrysler, Ford, and others, are celebrating this and implementing this. This was used in a joint venture with GM about 25 years ago. I don't know if anyone remembers Geo, the car brand Geo, but Geo was literally Toyota cars with GM manufacturing. And it was a joint venture for Toyota to teach GM how to do lean manufacturing. And it failed because GM and a lot of the American companies were not on that level of efficiency yet. And now that is what everyone does. So it started in manufacturing. It's a mindset of continual improvement, and you're benchmarking all of these improvements. So it's not just having a retrospective and forgetting about it, but it's tracking this and making sure that you are improving, and through some form of data that you can track. Trust in team members is a big part. If you are a supplier of Toyota, it is very crucial that you are a part of lean, but then also that you become trusted as well as you begin to trust Toyota. Predictability, that's something that you'll hear a lot of in lean construction as well as lean manufacturing, is trying to create the most predictable workflow as possible. And then eliminating waste. Toyota went back to Japan, and the group of people that were visiting in America, they went back there, they started identifying what is waste, and they identified inventory as waste. So they started to eliminate that waste, and they were able to gain a lot of efficiencies in that. And then adding value is realizing in your process, your work process, what does not add value that you can eliminate as waste, but then also what are we doing, what is a person doing, what is a company doing that can add more value, and predictability lends itself to adding more value. So there's 7 types of waste in manufacturing, and that carry over into construction, but it's overproduction, inventory, excess processing steps, motion, defects, weighting, and transportation. So all of these, they started analyzing, and if you study manufacturing as well, they identify each of these types of waste and educate everyone, and it's not just management. Lean really starts with, as we will talk about, the last planner or the person on that assembly line, educating them to really know what is, identifying what is waste, how to improve that and eliminate that waste or reduce it as much as possible. So these are very critical in creating a predictable workflow in manufacturing. There are 14 principles of Lean that I'd like to go over and highlight some of these, but these are very critical, and when I'm teaching a class or when I'm teaching people on this, it's a continuous improvement mind shift. So you've got the tools that you use in Lean, then you've got the cultural change, and then you've got the philosophical or the philosophy of this. And so you'll see some of these carry over in the principles of Lean. So base decisions on long-term goals, even at the expense of short-term gains. So what they would do at Toyota is they realized that there is a long-term goal that they did not want to sacrifice. And so in the short term, they might have to lose money maybe in a certain quarter or a certain portion of that quarter. Maybe they would gain inefficiencies in that quarter in order to, in the long term, gain overall efficiencies. So it's the idea of really establishing long-term goals and then not caring about gains as much if your goals are the central focus of the organization. Another one down here is level out the workload. That's something that's very critical we'll see in the carryover from lean manufacturing into lean construction. Build a culture of stopping to fix problems. As we all know, in the recent years, Toyota's had many problems with some of their cars, and so what they did was they stopped everything, went back and fixed everything to make sure that they were still in the process. Lean does not fix all problems. It's not the silver bullet. It's not that if you do lean in manufacturing or in construction that you won't have any problems, but it's establishing a culture to fix as many problems as possible. And then use visual control so no problems are hidden. This is something I highlighted that we will see in the lean construction side, and you'll see in some of the tools that are used in lean construction. Grow leaders who thoroughly understand the work, live the philosophy, and teach others. This is very critical. And the story at Toyota is how they implemented the brand Lexus. As we know, that's a very good luxury brand of cars. So they had a long-term goal of realizing that in order to increase their market share, they needed to develop a luxury brand to go after the BMWs and Mercedes and such. So they wanted to develop a very good, outstanding brand that they could bring to market very quickly. So they did not hire somebody from BMW or Mercedes or some of these other well-known luxury car brands. What they did was they brought in an engineer on the manufacturing floor, and they brought this person up who had been an engineer for many years with them. They understood the principles and the philosophy. They brought him in to really lead the group to establish the Lexus brand. So it achieved two things. One is an impeccable quality for this brand. Then also it worked along with the flow of their other cars that they were developing. So it became a very successful brand in itself. Go and see. This is one that is used a lot at Toyota, and it's something that we'll talk about in lean construction. But it's everyone from the president, CEO, to the person along the line. If there's a problem, everyone gathers around that problem and they go and see it. So that's a very critical principle. And then make decisions slowly by consensus and implement rapidly. That's another one I highlighted where it's intentional that they slowly are analyzing all the data. They're analyzing all the options, and we'll see this in the use of lean tools, but they want to plan and predict as much as possible so that when they start to implement, then they can eliminate all the efficiencies when they implement this type of decision. So that's a very critical principle in lean construction. So lean construction was developed based on lean manufacturing. Lean construction was developed by Greg Howe and Glenn Ballard. They both are they're in the Bay Area, San Francisco Bay Area, and affiliated with University of California, Berkeley. So they were studying the construction industry. They both were involved in the construction industry, and they started to realize how many projects were becoming very unpredictable, very slow, or they did not meet their schedule, they were over budget. So they started to do some research, and they formally started in 1993 the Lean Construction Institute. And in the California healthcare system, there's a lot of regulations and a lot of inefficiencies there. So this type of process worked very well out in the California, gained a lot of efficiencies in the California healthcare system. So there's many different reports that have stemmed from this, and if you would like to see some of those reports, I can definitely send those to you. But sharing that many of the inefficiencies of construction were upwards of 50%. So they realized that only 50% of the tasks that were getting done on construction job sites were what were planned, and so there's a great amount of improvement that was needed in construction. So they developed these tools, and there's a set of tools that they have developed to create predictable workflow. A lot of the same principles that we just went over in lean manufacturing, but many of them were able to, like I mentioned, creating predictable workflow and establishing trust among each other, and creating a sense of teamwork that's involved in planning this. Many times when you're on a construction job site, you've got three different parties that are against each other. You've got the owner, you've got the architect and design team, and then you've got the construction side. And so many times in a traditional either lump sum, see them at risk type of project, those are put against each other to drive costs down. And there's many inefficiencies there. The teamwork has been lost. Sharing of information is very inefficient. So these tools, these lean tools, help to foster better sharing of information, better teamwork, to gain efficiencies of this, to make a more predictable workflow in the delivery process of a project from design to construction. The first tool I'm going to talk about is the last planner system. And it's a system of tools that involves several tools: the pull schedule, the weekly work plan, the daily stand-up meetings, the percent plan complete, 6-week look ahead, and make work ready. There's other tools that I'll be talking about as well, and it's choosing by advantage, target value design, value stream mapping, the 5 whys, quick and easy Kaizen, first run studies, and then plus delta. And we'll talk about these. There's many other types of tools that you may have heard as well, and we can address those too if you have any questions about those. But I wanted to focus on these tools because many times they are not as studied as much as the others. So pull planning is the first step in the last planner system, and the last planner system is named the last planner system because it's getting the last planner involved with creating the schedule that they're going to be involved with. So whether you're a designer, architect, MEP engineer, structural engineer, it's getting the person who's literally going to be at your Revit station, your CAD station, however you draw, and the person who will be drawing the piping, the duct work, the routes, getting them involved in that schedule. Another one is if you're on the construction side, the laborers, the foremen who are literally going to be in the field that are going to be performing the work, they're getting involved with creating the schedule. So there's, in poll planning, you see a lot of sticky notes, and you see a lot of different collaboration meetings going on in poll planning. So I'm going to walk you through this and what is happening in this poll schedule. First of all, each color represents a person, a part of that. So you may have yellow is the electrical engineer, and blue is the architect, and green is the plumbing engineer. So when you look at this board here, if you're orange, you automatically can see, utilizing the principle of lean that we addressed, which was visual control, you can automatically see where your tasks are in this poll plan. And if it's purple or pink or blue, so on and so forth. So you can find out quickly where your tasks are and how you need to plan accordingly. The second thing is, each sticky note is a simple way, this is a very simple way of showing what is in each of these sticky notes. You have, first of all, your task up at the top. So that might be, if it's on the construction side, installing air handlers, or installing steel beams, or pouring concrete level 1, or slab on grade. It's a simple task like that. And then on here, on this section here, on the left side is handoff. You can list all the different items that you need done in order to start and end your task successfully. So that really helps trigger what the person before you will need to be creating in their task. And this could be tasks that your company needs to do beforehand, or it could be tasks that you need another trade partner or a consultant to do. And then on this side, you have your what's called durations and your manpower. Once again, very simple. These are Post-it notes, 4x4 Post-it notes, not very high-tech at all, and it is not it's not utilizing anything that's really complicated, because the process can be very complicated. So we, in teaching people, we start very simple with the type of tools that we use to carry out this process. So we have duration here, and we have manpower. So the person that is going to be doing this task, they can tell you how long they're going to be doing it for, and the manpower, how many people they're going to be associating with that task. This is different in a way too, because you start with the last task that is going to be done on this project, and you work backwards from that. So, case in point, if you're doing a 2-year hospital project and you're building it, it would be a long meeting if you started with, say, getting your final inspections, or owner moves in, and you work back from that and plan all the different tasks along the way. What I would suggest doing is breaking up into milestones. So you could pick the first milestone, maybe that's structure complete, or maybe it's even smaller than that, it's slab on grade complete. And then you work back from that. So the last task would be finishing slab on grade concrete, and then you would work back from that. Or maybe it's you're an architect and or a design team member, and so maybe it's schematic design complete, and that's the issuing of schematic design, and then it's design development. Or maybe it's broken up into schematic design of a certain area because your schedule is so big. But however it is, typically you want to do about a 10 to 12 week duration in your poll planning. And so you would start with the last task first, and then you would work backwards. And here's some other poll planning pictures that we have here. This is a poll plan here where everyone's working backwards, and you can see all the different tasks up here. This is a smaller one, and you can even, on your poll plan, you can write different notations of certain critical items, such as I've done here where it's exclamation point. That was a high duration process right there that was throwing off this whole poll plan, and so we really needed to focus on that. And then these are critical dates that I just circled that couldn't move, so we had to establish that in the process. And then we've got a question mark down here. So you can write all over these schedules, and it's great using Post-it notes or something similar to that. You can do it with tape that removes easily, is that you get everybody up there to plan this work, and everybody, just as we saw in the first picture, everybody is collaborating in this picture. You get everybody talking about their processes. You can move the sticky notes around, who goes first. You're talking, you're collaborating. You're really talking about these handoffs that I mentioned, the items that you need done beforehand. When you're doing a pull plan, you have a lot of conversations starting where people are asking, well, when you say you're done, what does that mean done? Does it mean, if you're an architect, schematic drawings are done, does that mean that we have issued them to everybody, or does that mean that in-house they are done, or does that mean they're on the title block, and what type of title block we're using? So you're starting a lot of these conversations beforehand that typically don't happen until the task is starting and that person is constrained, and it creates inefficiencies in the workflow. On the construction side, we're discussing a lot of coordination issues that are happening weeks in advance when the last planners, the laborers, the foremen, are actually on the job and going to be doing the work, so that we can flush out those constraints and those problems beforehand. So we're working backwards because it really does determine what task we need to be done in order to get this last task done. It really helps determine the critical path. Now you can have a secondary one, as we see down here, where it's items that still need to be done, but they are not critical towards this path. So you could break it up that way if you would like. You could even draw, if you wanted to, at the end of the full plan, your critical path, just taking a marker and drawing through that so you can track that and determine your duration. So there's many different ways to figure out how to determine the critical path. But the best thing about pull planning is that it's very collaborative. Everyone's involved in this, and they have buy-in, and they all know at the beginning of this schedule that what is expected of them. Another reason why I like pull planning is when you have manpower on here, say for instance the electrical engineer is pink in this picture. When you have manpower and they have associated with every task the number of men that will be working on a job, you can quickly determine the amount of manpower needed for a job and if they can give that to you. So if a design consultant is designing and they realize that they have reached their max of their entire firm, then you can start talking about how to optimize the process, how to make it more streamlined, or maybe put different types of tasks later on in the project so that they can stay at the same amount of manpower they planned for. So it really helps to optimize everybody's planning in a very collaborative way. So we've got pull plan. The group performing the work creates the schedule. The group meets in a big room, and all efficiencies are evaluated. So everyone comes together. Usually the meetings are 3 to 4 hours, but everyone works out a lot of these inefficiencies. The schedule is created backwards, pulling tasks into the plan, eliminating wasteful tasks. So as I mentioned, you start with the last task and you work backwards because many people will think that their task needs to be done in order for that next task to be done, but you may find out in the scheduling process you don't really need to do that. And the handoffs between tasks are discussed. So that is something that's very critical and very beneficial in a pull planning session. So the last planner also has the weekly work plan. Once you do the pull planning, you have the weekly work plan, you have the 6-week look-ahead schedule, make work ready, you have the percent plan complete, you have the daily check-ins, and you have the constraint log. So with a task, you have so many things that are associated with that task. Maybe it's on the construction side, maybe it's approved shop drawings, maybe it's labor, the space inspections, prerequisite of work. All these things influence this task. There's many different predecessors, many different unpredictable types of actions that are all affecting this task that you want to flush out beforehand. And that is the goal of the last planner system. The goal with Lean is, as I mentioned before, it's not a silver bullet where if you do Lean in design and construction, you don't have any problems. The goal with Lean is to try and bring up all the problems beforehand in a time frame that you can solve them, and it would create a continuous flow through the job. So lean is the opposite in that it recognizes there's many problems on jobs and does not ignore them, but brings them to the surface so that you can attack them, you can address them early on, and you don't stop the flow of that task. So we have a weekly work plan. And I'm going to go back up real quick to this picture I have both of, we've got the pull plan, so that's our schedule, and then we've got the weekly work plan right next to the pull plan. The pull plan covers about maybe 12 to 14 weeks of duration, and each of these tasks may have a duration of 5 days to maybe 5 weeks that you can organize in a way that everyone wants to build the project. The weekly work plan is set up by each day. So the task that took 5 weeks, you start planning each day what are you going to be doing on that task. And so we have a key here that we're using at one project where you've got the task that was addressed on the pull schedule. You've got the number of workers to check back with the pull schedule. You've got, then it's broken down to the floor and the area. So this is much more detailed work here, where every day each team member gets up there and discusses, okay, this is where we're going to be working. And it's a 10 to 15-minute meeting that everyone addresses what they got done, and if they didn't get it done, then why did they not get it done, and so they can attack that constraint or that problem right away. So we've got each day represented in the columns, and then in the rows we've got the companies that are part of this type of schedule. So these are the company names, and they represent different scopes of work. You can have this in design as well as construction. And so what you do is once a week, you have everybody put up their sticky notes beforehand. You would talk about what you're doing for the next 2 weeks so that everyone can plan their work accordingly. So that on Monday, if the drywall person is installing drywall and the electrician is planning on doing electrical work in that same drywall, then they can coordinate that work right away, or even talk about maybe the electrician would start later and let the drywaller work and get some work completed in place. So there's a lot of this coordination so that you don't go to the field and send tools and manpower to the field to put this work in place, and then they get to the field not realizing that this work was not even completed. And so now they are stuck with not doing anything. There's wasted labor on both parties and frustration. So this helps create a much more predictable workflow each day. And so you plan this for 2 weeks out on this one. PPC is something else that we'll talk about here, but it's tracking your percent plan complete. And we'll address this in a couple of slides. Another one that another board that they use, and they set these up, is the constraints. So anything that's constraining your work, you can put up here. And everyone knows that if a constraint pops up here, that everyone attacks it aggressively so that it keeps the flow of work going. Inspections are a very critical thing in construction. You can plan all your inspections here, and that's one way we can track and we know that their work is going as planned. And then deliveries. In many job sites that we have here in Dallas, there's a lot of constraints with traffic and site and inventory on a job site that we want to keep at a minimum, because many times increased amount of stored material reduces inefficiencies on the job site. You have to move it around much more. Damage occurs. All these different problems will develop if you have too much inventory on site. So we try to limit that as much as possible. Also, loading docks are sometimes at limited numbers. So deliveries can be a huge problem area for job sites. So we have everybody schedule their deliveries like this. Here's another way to do weekly work plans, and it's just through Excel. So we've got a similar thing here, and what's shown here in Post-it notes, we've got here in Excel, where you've got the week, what week you're working in, the area, the level, the subcontractor name, or it could be a consultant, whatever phase of the project you're in, whether it's design or construction. The commitment description, the handoff, what you need done, and then our inspections or material delivery included in this. And then you can have the min planned and the min actual that you have each day. So you can check off and confirm that you have done this. So you could do it through Excel, and you could do it through Post-it notes. And the reason why we start training with Post-it notes is once again, it's the simplicity of it, the visual control, that it's easy for people to catch on, much easier when you do it that way than with Excel. Excel is more advanced, and if people can understand Excel in that format, and if they're comfortable using it, then you can use Excel. So both ways work fine. So percent plan complete is something that I just alluded to, and I want to talk about this. So you train the teammates, whether they're consultants or subcontractors, you train to all aim for a percent plan complete rate that you're all going for as a group. And so what you do is it's a simple math where you take the items that you have done that week and you divide it by the items that you have planned for that week. And you can instantly start seeing the different rates of the people who are planning and a part of this weekly work plan. So I'm going to flip back up here real quick to this. And so we have the PPC right here where everyone's writing down their PPC. And here's another graph where you can do it in Excel, and you can list it this way. And this is not a building a case against people. It's not trying to show who's the weak link and really get on that person, although that does happen. And it's not it should not be used as a negative way, but as a more analytical tool for you to gauge what your team is doing. So for instance, let's say in the OAC meeting, you're tracking the PPC of everyone who is committed to doing certain tasks in the week. And maybe it's an equipment engineer here that they're tracking at 14%, the lowest one in the group. Well, that's something that you can all analyze the group and say, okay, why are they screwing up? Why are they having problems? What's their problem? Why are they doing this? And that's something that the whole group can analyze, is looking into, okay, how can we help that person become more predictable? What is really driving that rate really low? And I'll get into the 5 whys in a little bit, but it's asking that why 5 times to really analyze, okay, how can we bring this person up to become more predictable? Each of these rates are showing their predictability. And then maybe the structural engineer at 85%, maybe they have lessons that everyone would like to learn of how they become very predictable. And so they could share that. So you want to really start investigating the highest and the lowest person and see what lessons can be learned from each of those. And it's a way to analyze this, saying, okay, the equipment person is 14%. Okay, what's really driving that? And maybe you're an owner, and you're saying, okay, why is that so low? And so you start asking the questions, really trying to understand their low predictability, and you find out that it's because you're not getting the information to them fast enough. Maybe they're a hospital equipment planner, and they need to know what you're, as an owner, going to be buying in hospital equipment, and you need to make decisions for them based on certain technologies, and you're not doing it in a timely way. So it's a way to just really help them increase their predictability. So naturally, people as a team will get on that person who's got the lowest, and it automatically starts to bring them up because they don't want to be the lowest. They don't want to be talked about every week. So that's a very good thing. And on the construction side, it's the same way. So you want to talk about the PPC rate. You want to set an average of what everyone's aiming for. Usually, you want to do it between 60 and 70%, because as I mentioned in several reports, usually when you start tracking this, it's 50% or less of your tasks are getting done. So an increase of 10 to 20% is a huge jump. You're never going to hit 100%, and so that's the thing, is to get the team to set a goal that is very achievable. Another one that is here is called schedule variance. So when you have a constraint, you can label it as a type of variance of what is really constraining you. So as we pop back up here in the weekly work plan, right here is the variance that you can track. And you can do that with Post-it notes. You can do that in the Excel spreadsheet. But what you want to do is, if that task is not completed, then you can start tracking the schedule variance. You can track what is really delaying that. So you can see right away what is really driving your design, your construction, or even if it's in an office, what is really driving your variances. You can interchange weather and design changes in equipment and material with, maybe it's names of persons a part of your team. Maybe it's design, or maybe it's in the design team, so maybe it's different MEP and structural engineer, whoever. But it's really tracking, okay, what is causing the most constraints, not once again using it in a negative way, but it's really trying to establish a predictable workflow and trying to lower these variances as much as possible. You'll never eliminate all variances knowing that, but it really helps everyone to focus on, if we know that material delay is really driving this project, and every time we do a healthcare project it's a material delay, then it's really focusing on, okay, what material then? And asking those questions, okay, what material is really delaying this? And maybe you recognize that on all your healthcare jobs, the lighting is the biggest problem. And so you start to learn that as a designer so that you can start specifying maybe a different light, or maybe looking at the supplier and seeing how they can become a more predictable supplier to reduce that variance. Maybe it's a person, a part of a team, and you've interchanged these variances with a person. So it's really looking at, okay, why are they causing the most constraint? Maybe they have too many responsibilities, and they're just too bogged down, or maybe they're not given enough information, they're not trained adequately. Maybe there's a lot of other problems there that you don't see that you can help them in. So once again, it's really analyzing the process to try and create a predictable workflow. So that's the last planner system, and you plan it with the pull planning. You plan it in a daily sense with the weekly work plans, tracking your percent plan complete and your variances, talking about it daily in a 10 to 15-minute meeting. Another tool is choosing by advantage, and this is a great way to make very educated choices, whether they're design choices or whether they are personnel choices. And I've put in a slide here developed by a process and use at the U.S. Forest Service and National Park Service. So they analyze a lot of decisions by choosing by advantage. And this is a very high level, a very intense type of way to choose different types of options. The background is it allows you to really focus on the type of value that is the decision, the different decisions you are determining, and what it is that they are bringing to the team. So maybe it's a person that they're bringing to the team, maybe it's a decision, a design detail that they're bringing. Whatever it is, it's a great way to track this in an analytical way. Analysis process that seeks to eliminate double counting. So not giving one as much weight as maybe there's many different variables that affect the judging of each decision. Maybe it's a detail of a door that you're drawing, and you want to evaluate many different decisions on this, and so you want to track all the variables that affect the drawing of this door. And so you want to weight those accurately and not to double count the different variables that attribute to that design. And I have an example here of a spreadsheet that I can show you. An important feature of the system is that you're concerned with the advantage of the attribute and not the attribute itself. So you're really focusing on the advantages that they bring to the table. It can be used to help make any type of decision, like I mentioned, personnel decisions or design decisions. It's a decision-making system based on the importance of advantages. So once again, you're really focusing on the advantages and what each variable can bring. And then the last one, the disadvantage of one alternative is the advantage of another. So you're really looking at these. So here's a spreadsheet that a director here at Beck uses to evaluate people that they're interviewing for project manager roles. And it's a very intense spreadsheet when you first look at it. But over here is the criteria that they look for in hiring someone. And then they equate certain types of points to to each of those variables. So it could start off with maybe 3 or 4 that you realize, and then over the process of several different interviews, you realize, wow, okay, this criteria is important. Let me put that in there. So you track all these different criteria that you look for when you're interviewing someone. And you weight those based on all of these different criteria, that it can start bringing and calculating a score to that. And so then it automatically starts showing in a scientific way, okay, who is the person based on this score who is most qualified for that position, so that you can really focus on the 2 or 3 people that really filter to the top, and not really concern yourself with the other people that you may have thought that were higher. But this is a way to continually use in your processes and add to this and keep changing. So this is choosing by advantage, a great way to evaluate decisions. Target value design is another one that's used in the design side that I'll go through here, and it really utilizes the team in target value design. You bring a team together at the beginning of a project in construction, and you have everybody design to the goal. Target value design is itself a group decision to target which values that you see as very important to the process. So it could be budget, it could be schedule, it could be design awards that you're pursuing that you see as value, it could be end user values. So the idea is to engage deeply with a client in this, but then also with your team members to all go for this design. Design to a detailed estimate. Starting with a very detailed estimate, you're designing towards those areas of money. And then design the sequence of the customer who uses it, really analyzing how you're designing and using the design process to really gauge how the construction process will go. It's a very great tool to use in what's called an IPD process. It's another lean term that I'm not going to address in this meeting, but IPD is Integrated Project Delivery, and target value design is very closely affiliated with the IPD process. Co-location is great, having the engineers, architect, construction managers, even your major trades all move into the same location and work together and creating greater efficiencies. Working in diverse groups or cluster groups is a great way to help focus everybody on a design and solving problems in the design side. And this is not just the designers doing that, but it's also the person installing the work that are included in these groups. And then retrospectives during the process. That's very critical to make sure that you are doing what you all said you were going to do and tracking that. So here's a great example. I led a structural cluster group in a target value design project. And the blue is MOB and the red is hospital. And the MOB utilized cluster groups where we had the structural engineer, architect, general contractor, and the structural fabricator and erector in the same meeting. So we all designed, this was in the hospital, everybody was very collaborative. We all designed towards the goal of the budget and making a very efficient steel structure for this hospital. The MOB, it's the same team, same group of people, but the cluster group meetings were ended, and we did not do those in the MOB. So we lost a lot of efficiencies. And so as you can see in this graph, it shows that the wide flange, if you know anything about construction, wide flange beams are your main beams. Those are usually the most tonnage is made up in your wide flange, but those are the cheapest per ton to install, whereas your bent plate and angle are the most expensive to install. And so as you can see, our percentage of bent plate and angle were 20%, or almost double the percentage as what we had in the hospital. We had many budget issues with the MOB because of that. There was not as much collaboration, so we had to add a lot more miscellaneous steel in there to make up the lack of coordination. So a very clear picture of target value design and how it can work. And then value stream mapping is another tool that you can learn. Identifying current processes in place, and this can be used with anybody, whether you're in the office or in the field. Communicate the new process that you have all analyzed and then work towards that new process. So you take a process, and as I show in the next slide here, you take a process, and this is the diffuser, the steps of the diffuser from the design to the the installation of the diffuser. And so you analyze this and say, okay, what steps can we take away? What steps are not adding value? What steps do we need to add value to this to gain greater efficiencies and even value to the end user? And you analyze this, you create a workflow for this, and then you start, as I mentioned, working towards the new process and saying, okay, this is what we decided as a team, let's start implementing this. So this flow processing can be used in, maybe it's processing billing, maybe it's the way that you write contracts, maybe it's the way you hire people, trying to reduce the amount of steps as much as possible. Once again, going back to lean principles and your motion in your work that you do. Quick and easy Kaizen is a great way to do this, and it's not a suggestion box, but it's a way to write down an idea that a person who is doing actual work has, and then this person actually tests that piece of work and they come up with the report themselves. So they have some pictures here of they were receiving these in individual count, and then they started receiving them as groups, and it gained a lot more efficiencies this way. Higher quality is what was talked about here, implemented. And this is at a manufacturing environment. So you can do this in construction. You can do this, maybe it's evaluating, people's reviews or whatever the process is. But it's not just for people to come up with ideas, but it's a great way to have people come up with the ideas, but then test them and say, okay, this is the result of the test. This is why we see it as a value. And they can present that. They can post them on walls so that people management or people who are a part of teams in management that identify new processes can take these and learn new processes that people have developed, and then they start implementing these new processes in the organization. And then 5 whys, asking why 5 times. It's another great tool to really help problem solve, because many times we start solving problems that really aren't the root problem. And so we get done with solving the problem and we realize that it really hasn't fixed the problem. So you ask why 5 times. And basically, when you ask the first why, the process is to jot down all the responses to that first why, and then ask your second why to each of those responses, carrying it all the way down to the root cause analysis. So whether it's in the weekly work plan, the full planning, and any of the tools in Lean, you can implement 5 whys. So those are some tools for Lean construction that I hope were helpful to you and educational. So I have a few moments for question and answers. Does anybody have any questions?
We do have one that has come in. It says, how or why is it better to use Excel for weekly work plans if not everyone can continually see and interact with the Excel-based schedule at the same time? Doesn't this invite the probability of having multiple versions of the same weekly work plan existing at the same time?
Yes, that's true. Now, what we do is we send out the weekly work plan Excel spreadsheets to all the team players involved, and they fill out their own and they send it to you, and then you compile it into one weekly work plan so that everyone's on the same page there. You can send that one with everyone's weekly work plan in the same spreadsheet, and you can send that out for everyone to analyze and discuss, and that's what we did in meetings is go through each of the line items. But yeah, you want to make sure that everybody is all together on the same weekly work plan, so make sure that that happens on that spreadsheet.
Another question that's come in, what are the biggest challenges facing implementation of Lean construction policies?
Many times in Lean construction you have people that are very experienced in what they do, and so they don't think that they are doing anything bad. They just think inefficiencies and problems in construction are just part of the nature of construction. So it's really, I think, getting over the hurdles that, first of all, you have a problem to begin with and that there's inefficiencies. And so once they start recognizing that, I think then they start being more open to being educated. But I think it's a long process to show people what their inefficiencies are and talking to those inefficiencies.
We did have a recommendation come in from one of our attendees. He said that he recommends using Google Sheets for the process that you described about using the work plans in a Google spreadsheet.
Yeah.
He said that allows for one version of the work plan that everyone can interact with simultaneously.
Yeah, no, that's great. I mean, there's many different ways that you can do it, whether it's Post-it notes or Excel spreadsheets or PowerPoint or Outlook, whatever works best for you. But the idea is to make sure that everybody, carrying on the principles, that everybody is coordinating their work on a daily basis.
Well, and Jason, you also shared with us the weekly work plan Excel spreadsheet. Are you going to make that available to our attendees? Can we send that to them?
Okay. Yeah.
Attendees, whenever I send out the recording of today's presentation, I will include that Excel spreadsheet in that email. And then moving on to the percent plans complete rate, who decides that percentage?
So the actual percent plan complete of a person is decided by the amount of tasks that they said they were going to do. So on the weekly work plan, and I'll go right back to that picture. So say, for instance, this one, and I don't know if anyone can see, but it says Baker, this second line on this slide. Baker has all these tasks here, and they've planned this amount of tasks. Now, they've also committed to doing these tasks. So percent plan complete, who decides this percent plan complete is basically what tasks they said they were going to do, and the team agreed that they did do. So they can strike those out. You could just draw a line through the task that you did. And then you divide the task that you said you were going to do by the task that you planned. So this percentage is simple by dividing the items that they said they did by all of these items right up here. Now the goal, the percent plan complete goal, like say for instance you establish a target goal for everybody to strive for, that's agreed upon by the team. And so that's agreed upon at the beginning of the job or at the beginning of the implementation of Lean, is you say, okay, what goal are we going to go for? And you may say it's 40%, and everyone exceeds that a lot, and so then you have to change it again. But that's okay. You can continually change that if you need to.
And our last question for today, if there are more questions that come in, please continue to send those to me, and you can type them in, and we'll make sure that Jason answers those in a response. Since Lean processes came from the manufacturing side with Toyota, and then now the construction industry is starting to implement them, is this something that's reasonable and doable for every firm? Do you have to be a large firm to implement this, or is it something that a small company can actually follow through with?
No, it actually works better at a smaller firm, because I've found that smaller firms are more nimble, and that especially if you're doing project management and superintendent, if you're a construction firm, or maybe you're an architect and you're doing multiple roles, this actually helps your efficiency, your processes. It's not as time-consuming as people think, but I think smaller firms, you gain, just like Toyota, when they started, they were very small, and now they've become very efficient, where they've become one of the largest, if not the largest, automobile manufacturing company. So it actually lends itself to helping the smaller companies